These are the topics we're going to cover in this talk. Delegates, both the ones provided by the standard lib and creating your own delegates, making infix functions using the infix keyword. There's a keyword in Kotlin called where, which a lot of people don't know about. It doesn't come up often, but it's a bit of a lifesaver when you do need it. Most people have used some annotation useIte targets. That's where you do like @get : and then an annotation name. There are 9 available in Kotlin, so we're going to look at all of them. We're going to put them in Kotlin code, decompile the bytecode back to Java, and see where those annotations actually end up in your code. There's a keyword in Kotlin called tailrec, which can make co-recursive functions not actually be recursive in your compiled code. So we'll see how you can use that and when you can use that and how you can convert regular recursive functions to co-recursive functions so that you can actually apply that keyword. There is a ton of content here, and I have a section on sealed classes. If it looks like we're running out of time, I'm actually going to cut that one. I have a feeling most people have used sealed classes already, and it's not that advanced of a topic, but it is very important. So if you haven't looked at them, you should. We'll go through them if we have time. Another topic that I was going to cut out was in and out keyword, covariance and contravariance, and I was asked to keep them in because a lot of people have said they've seen that before, but it hasn't clicked. So I'm going to take a different approach at explaining that topic. We're going to look at the reflection APIs in Kotlin and do a little bit of a dive into building DSLs using Kotlin. So there's a bunch of stuff to go through here. But quickly, the target audience for this talk. So if you know none of these, I would say this talk's probably not for you if none of these look familiar at all. And if you know all of them, obviously this talk's probably not for you because you know it all. This is also the exact same talk I gave at droidCon New York a couple months ago. So if you were at that talk or saw that talk online, there's nothing new here. That being said, if I've convinced you to leave, there's some fantastic talks going on at the same time as this one. So please feel free to get up and go. I won't be offended. If you're still here, let's jump in. All right, so delegates. So most people have used lazy, provided by Kotlin. You've seen code like this. You've probably written code like this. The standard library actually gives you 4 delegates. Lazy is one of them. So we're going to look at the other 3, being ones you might not have seen before. So they're observable, vetoable, and not null. So observable is in a class called delegates, uppercase D delegates. So it's uppercase D delegates.observable. You'll import it and use it like this. So it takes 2 arguments. It takes an initial value, and it also takes a lambda. And that lambda will take the property, the old value, and the new value. So now every time that this value changes, your lambda gets executed. You can see the old value, you can see the new value. So a good way to sort of drive one property off of another property, if you want to do something like that. Vetoable has the exact same method signature, except the difference is that if that lambda returns false, the value actually won't change. So this is a good way to make a little thing so that if you're outside of any sort of bounds, your values won't change if they shouldn't. And then the last one is not null. So not null is a very simple one. If you try and reference one of these values before the variable is set, you'll get an illegal state exception. So the question is, what's the difference between this and late init? Late init you actually can't use on primitive types. So with one of these you can. If you want to make your own delegates, if you want to make a delegate that's only used by vals, you have to provide a get value method with a very specific method signature. If you want a delegate to be used by vars, you need the same get method and a set value method. And because delegates are actually a compiler feature, you don't have to necessarily implement a specific interface for things to be converted to delegates, but the standard library does give you these 3 interfaces that you can implement to make it easier to meet the get value and set value contract and not mess up any types in that. I also recommend using these even though you don't, simply so that when other developers jump into your delegate code, it's obvious that what you're building is a delegate. And if it's a new developer, they can look at these and read the docs on these things. So let's look at the first one. If you want to make a delegate for a var that you can read and write, this is how you would do it by implementing this read-write property interface. So this is what get value and set value methods look like. So there's a very simple delegate that actually doesn't do anything but hold a value. So it has a private variable value within the class. It has a get that just returns that value and a set that sets that value. And then this is how it would be used when you're going to use it. So there's a very simple way to make your own delegates. The 2 generic types on a delegate, or on this interface to build a delegate. The second one's probably pretty simple. It is the variable type that you're working with, right? So in this case, we just sort of punt that to the client so that they have to provide it. The first generic property there is maybe less obvious what it is. That has to be the type of the thing that contains your delegate. So if you were building a delegate that you only ever wanted to be used within something like an Android fragment, then you'd use fragment there. And then that delegate can only be used within a fragment. And then in the 2 methods that we implemented, you see you get a reference to that thing. So then you could use context or something like that from fragment. In almost all cases, any is the right thing to use there. As long as your delegate can be used, globally. Like I said, that interface is actually optional. So this code is the exact same. So same method signatures with the operator keyword on them, and this works the exact same way. I guess it's sort of interesting that the lazy delegate that we saw is actually implemented using something like this. So lazy is actually a top-level function that returns an object that is capital L lazy, and its get value methods are actually inline operator functions that are extension functions on the lazy type. So that's how they build them. So you could do the same if you wanted. Like I said, I'd suggest using the interfaces just so it's obvious what you're doing in your code. So we looked at read-write property. The second interface type to build delegates is called read-only property. So this is if you have something that's just that's a val instead of a var that you don't need to change. If you were to change this usage type to a var, the code just wouldn't compile. And the last one actually isn't an interface. It's an abstract class that itself implements the first interface that we saw, read-write property. And its default implementation that it gives you, it has a before change and an after change method. The before change by default returns true, and then the set value method checks to see if before change returns true. If it doesn't, it won't update the backing property. And then after the value's changed, it calls this after change method. This might look familiar, like the built-in delegates that we get from the standard library, and this is exactly what they actually use. So Vedable uses this exact thing out of the box. So if you want to adjust it a little bit, you can use, you can extend this abstract class and do your own thing. All right, this is an Android conference, so I should give you some Android code. So this is a delegate that you could build to drive shared preferences. So at the top, you'd grab a lazy instance of a shared preferences object, and then in get value, let me back up to the very top. So it will take the key that's going to be in the shared preferences and default value. So in get value, it's going to look at the type of the default value and call the appropriate method on shared preferences to either get Boolean or get int or get string, et cetera, et cetera. And then the same thing in set value, it'll look at the type of the default and call the appropriate put, and then do an apply at the end. So I just noticed my slides are a little washed out. I don't know if it's possible to kill the lights up front. If so, can we do that? That would be great. So the usage is at the bottom here. So it's by my delegate name, and then you just using the default value, it knows which type to read and write. So if you don't have something like this in your code already, I suggest you copy this one. There's some other open source implementations of similar delegates that drive shared preferences in Kotlin that you could just Google. All right, so that was delegates. On to infix functions. So if you've never heard of infix functions or used built-in infix function, you actually probably have used them. When you build a map and you use this to operator to construct pairs that are being added to a map, to is actually an infix function. So instead of calling it this way, you could call it this way with a dot and brackets on the end. And the reason why you can call it how it's shown at the top is simply because the to method that construct pairs has this infix keyword assigned to it. There's other things like this in the standard library, such as down to. And I actually looked at the entire standard library, and we're going to look at all of the infix functions that are available in them, because there's not actually that many. All right, so when you build your own, the rules are pretty simple. You have the infix keyword. It can only take a single parameter, and the parameter can't be a var args. You can't have a default for that single parameter. It has to be a member function or an extension function. So here is an example of building one ourselves. Let's say I asked you to create a class called card that represents a playing card. This is probably what everybody would do. You would make an enum of suits and enumerate all the suit types, and the same with rank. You make a data class called card that holds those things, and you create one like this. And then, step 2 might be adding a method to rank, so that you can say, start with rank, call .of, pass in a suit, it constructs a card and hands it back to you. And then it starts to look a little more like English, right? 7.of diamonds. If we add the infix keyword there, suddenly it looks like a DSL, right? So 7 of diamonds. My rules that I suggest around using infix functions is don't overuse them. Simply because they cause sort of mental developer pause when you encounter them in code. If you came across this 7 of diamonds in code, you might be like, oh, what is of? Because it sort of looks like a keyword when it's an infix function. So use them sparingly. The best place to use them is if the person writing code knows they're within some sort of DSL context. I think the Mockito Kotlin library actually does a very good job of this. It's a somewhat largest library, and it only has 2 infix functions, one called doReturn, one called willAnswer, so that you can, again, you're within DSL context, and this doesn't look that strange within this unit testing code. Right? All right, so all of the infix functions in the standard library are the following. All the bit shifting methods are infix functions. All the bitwise methods are infix functions. Those make sense because you want them to sort of look like keywords. There are 2 on char sequence that you can use on strings. One is matches. The second argument is a regular expression, so you can have string space matches, space regular expression. That will work. Same with zip. And then 4 on iterables. Zip, and then intersect, union, and subtract, which will return sets of those 2 iterables. All right, so that's infix functions. Next, we'll look at the where keyword. Like I said, this is a keyword in Kotlin that you might not ever encounter, but the times you need it, you'd actually be stuck without it. So it's good to know about. Awesome, thank you for doing the lights. All right, so take the top example. So I have a function called print until. It takes a list of items and an item that you want to stop at. So let's say we were to call this with a list of the numbers 1, 2, 3, 4, 5, and you want to stop at 3. Items.takeWhile will continue to take from the list until it hits stop at. So take 1, it would take 2, it would stop at 3, and then it would fall to the let, and you'd end up printing out array 1, 2, right? Or list 1, 2. If you then realize that you actually want to print the 3, let's say, and you also realize that this thing's ever only going to take numbers. So the obvious thing would be to add a bound to the generic type to say this is number, and I want to take while it is less than or equal to the stop at to try and get 1, 2, 3. This code actually won't compile. And the reason is that number doesn't implement comparable. So in this case, you want something that's a number, and it has to be comparable. So things like int and long, capital integer and long, they do implement comparable, but its parent type number does not. So to fix this, you use the where keyword. So the where keyword looks like this. So you take the bounds off of the actual generic type, and you put it at the end of the method signature using the where keyword. So in this case, you can specify multiple bounds for your generic types. So in this case, it's where t is number, and t is a comparable against t. This is just alternate formatting of the same thing. Makes it look a little cleaner. So that's the where keyword. All right, usite targets. You've probably seen the 2 up above and maybe some of the other ones in this list. So there are 9 usite targets. So it's at, and you specify one of these targets and a colon, and then your annotation name. So what we're going to do is make annotations, put these in actual code. I've decompiled the bytecode back to Java to see where your annotation actually ends up in the Java equivalent of your Kotlin code. So we'll start with the easy ones that you might have seen before, and where they end up should also be apparent. So I make 3 annotation classes, one called getAnnotation, setAnnotation2, and the last one called setAnnotation, then setAnnotation2. And the reason I made 2 setAnnotations is just to show off that if you want to do multiple annotations on a thing, you can actually use a square bracket syntax, and it's a space-delimited list of annotations. You can also do @set1 and @set2, that's fine, but there's sort of a smaller version of that. All right, so if we look at the Kotlin bytecode, decompile it back to Java, this should be as you would expect. So this person class has 2 private fields that are not annotated. The getter for first name has the get annotation. The getter for last name does not. The set annotation for last name has both annotations applied. All right, hopefully that was an easy one. Now, there is @param and there's @field. So what is the difference between those 2 things? So I did the same thing. It's the same person class. 2 annotations, one called param annotation, the other called field annotation, and I applied the param annotation using the @param usite target to the first, field to the second, so to last name. And if we look at the compiled code, the field for last name is the thing that has the field annotation on it. So good job, Kotlin, you named that thing great. And in the constructor itself, @param annotation is on the parameter for the constructor variable. So if that's where you need your annotation to live, that's when you would use @param. There's @receiver. So this is how this one looks. If you were to make an extension on string called is not null or blank, as most people know, that actually turns out, when you decompile, to be a static method whose first parameter is the thing you're acting on. That thing you're acting on is called the receiver. So in this case, that's where that annotation ends up. It ends up on that first parameter that Kotlin hides away by being the extension type that you're acting on, which is the receiving type. In the compiled code, that first parameter has the receiver annotation that we created on it. There's another one called @property, but the documentation for this one says this annotation is annotations with this target is not visible to Java. So when you decompile the Java code, you don't see it anywhere. So to figure out the difference for this, I used some reflection code to find out where it lives. So I made two properties. One you pass in from the constructor. The other one is in the actual class body itself. And then in this main function here, on my class, I can get member properties, and in a for loop, I'm going to print out the name of the property and then annotations on that property. And then in the second for loop, what I'm doing is I'm grabbing the constructor, using reflection, and getting all the parameters for that constructor, and then looping through those and printing the name of the parameter and the annotation. So if you take a look at the output, you'll see the properties, the two properties, both the constructor one and the one in the class body have the property annotation applied, but the actual parameter to the constructor has none. And second last one, the @delegate annotation. So I want to know how that differed from the regular @get annotation. So I applied both of them to the same variable in this class. And the variable is delegated using lazy. So when we looked at delegates, we saw this capital L lazy, which is your delegate type. So that is the private field in generated code that's actually going to have the delegate annotation applied to it. The actual getter, which uses the delegate, will have the regular get annotation applied to it. The last one is @setParam and how that differs from regular @set. I won't talk through the example of this one. If you look at it, the setter itself has the @set, and the parameter that's being passed into the setter is the thing that has setParam. So those are the 9 different USI targets in Kotlin and where their code ends up. All right, so there's a keyword in Kotlin called tailrec that you can use to make co-recursive functions tail recursive. So the reason why you do that is that a regular recursive function is limited by your heap size, right? So if you recurse too far down, you'll get a Stack Overflow exception. But if you can add tailrec to the start of something, the compiled code is no longer recursive. So it's not actually limited by your heap size. Okay, so the difference between recursive and recursion and co-recursion. So recursive functions, you guys know this, recall themselves repetitively. They have to finish calculating, but before you can return, like I said, they're limited by the heap. Co-recursive functions are similar, but they have some extra rules to them. They call themselves indefinitely, like an infinite loop. Each step is actually evaluated at the time it happens. It itself has to build up a value that can be returned and has to have like an exit clause once you can return that thing. And then these things don't have to anymore be limited by the heap size. And usually trying to convert a recursive function to co-recursive function, it's easy if you sort of try and think about it, sort of solve it backwards. So we're going to look at a couple examples because this might not be quite clear what's going on. Okay, so make a function called factorial. So in math, if you do like 5 bang, that's equal to 5 times 4 times 3 times 2 times 1, which is 120. The regular recursive way to do this would be to say if n is 1, we're done, we're going to return it. Otherwise, we're going to take n, we're going to times it by, and then recursively call the same function and take 1 off of n. So you can see how this has to complete. Like you could essentially take the method body of this and paste it in where you have factorial and keep doing that 5 times. You have to complete, and then everything has to run before you can return. So this is a regular recursive function. If we want to make this co-recursive, we could do something like this. So the exit clause is once n is equal to 1, we're going to return the total. Otherwise, we're going to pass in n minus 1, and we're going to ourselves maintain the total. So this is the important step. So now you can see that there is an exit clause, and you don't actually necessarily, you don't copy paste sort of mentally the function in here anymore, right? Because you're passing all the data that you need. So instead of thinking about it like pasting, you end up with this long thing. This thing's going to call itself with one set of parameters, then call itself with another set, and call itself with another set till it's done. So that is a tail recursive function. So you can add the tailrec keyword to the second one. If you add it to the first one, your IDE is smart enough to just tell you, sorry, you can't do this. So if you have a function you're not quite sure if it's tail recursive, just add it. And it will still compile. It just will still be a recursive function. But the second one, you don't get the IDE warning. And when you decompile it, this is what they look like. So the first one stays recursive. The second one, the compiler is smart enough to unwind it into a while loop for you. That's pretty cool. One more example in case you want one more, just for clarity. This is how you would do a regular string down that keeps slicing a value off the end of a string and printing it out each time recursively. You can see how this has to build itself up before it can spit out a value. Here's a tail recursive example. So one of the keys is always you're maintaining your own sort of output at the end, the thing that's going to be returned, and then you have an exit condition. You'll also realize that the first time you call this, you have to pass in some sort of default value for the output string, which is a little weird. So it's very common to wrap your tail recursive functions in an outer function. So you have an inner function, which is the tailrec function. And the outer one just takes the value you actually care about, defines the inner function, and then you end up returning, and you call the inner function with a default for the thing that the client shouldn't really care about. So that's how you should implement these. All right, we are running low on time, so I am not going to cover sealed classes, but you should take a look at them if you don't know about them. They are awesome and great. All right, so on to covariance and contravariance. But just a quick sort of trivia thing. What's the most overloaded keyword in Kotlin? My example is that you can use as to either rename an import or as a cast. Does anybody have a guess? I heard some mumbling, but I didn't hear any answers. It's the in keyword. So in can actually be used for for loops. It can be checked if something's in ranges, and the same thing in when statements. And it can also be used as a keyword to mark things as contravariant in Kotlin. So like I said, people asked me to keep this section in because they were still confused about covariance and contravariance and bounds on generics and these sort of things. So I'm taking a little different approach to it, and hopefully this makes it clear if it's still fuzzy in your brain. So essentially, if you have a class that can only give you things, you can add out to its generic type. Hopefully that's very straightforward, and that's it. If you have a class that is only going to receive things, you can add into its generic type. But the real sort of pro tip here is that your IDE has this this check called type parameter can have in or out variance, and it doesn't have a warning color by default. So I suggest that you go and turn this on in your IDE, and then when you make a class like my giver class that it knows can have the out variant applied to it, it'll just tell you that. So go turn that on, and then when you're doing code reviews, you can look like the rock star and tell someone, hey, this thing should have an out variant. All right, so how this actually applies to variance, so the word covariant and contravariance, when you have this in and out keyword. So hopefully the first part made sense, and if you sort of forget about variance, that's fine. Just remember in and out, and Kotlin makes those keywords obvious, unlike Java where it's extends and super, which isn't quite as clear as when you should use each one. So here's an example. So I made this class hierarchy. At the top we have hardware. In the middle we have phone, which is always a type of hardware. And under that we have phones, which are Android, BlackBerry. I could have listed a third one, but I ran out of room. And then a class called manufacturer. And it has a generic type that can only output values that are of type hardware. A second class, which is, so that's my producer. The second class is my consumer of things. It's my driveway, which likes breaking my phone screens. So same thing, it has an in generic type, again, at the uppermost bounds of this class hierarchy called hardware. All right, so this is variance if it hasn't been clear to you before. So I'm gonna make a producer and I'm gonna make a consumer, manufacturer and my driveway. The types that I'm going to give it for that generic type are the things in the middle of that hierarchy is the phone. So there's hardware above that and my versions of phones below that. All right, so I have a producer and a consumer, manufacturer and my driveway. It should be obvious that your producer, when you call create, you know that's going to be a phone. We've told it you're making phones. Same with consumer. When you call please shatter my screen, you can pass in a phone because we told it the type of things it acts on are phones. When you call create on your producer, you can also assign that to hardware because a phone is always going to be a type of hardware. Consumer, you can also always pass things that are of type phone because it knows it can smash phones and it knows that an Android is a phone all the time. So these are fine. Where the compiler will yell at you is when you go on the opposite sides of this graph. So for the producer, if you tell it to create something and try and assign it to type Android, the compiler will not allow that unless you do an explicit cast on it. Because you've told, using the generic types, you've said this is producing phones, but we can't guarantee that it's going to be an Android phone, not a different kind of phone. Same with the consumer. You cannot pass it a kind of hardware because it doesn't know that could be something else in this class hierarchy that is not a phone. It could be something else that is type hardware but is not a phone. Yes, so this is how, so the first case of the producer is covariance, the second is called contravariance. Hopefully that clears it up. Reflection. So we're gonna look at some reflection stuff in Java. Sorry, in Kotlin. We're gonna talk about this .java thing. So most people have seen this because you have to do this when you interop with Java. Most people think there's a little bit of magic, right? If you need the Java class, you do : class.java. You think it's just some weird language thing. But if you dig into it, you know, all the magic boils away. So when you do : that's a reference operator. So if I just look at the demo : class part, that is a reference to something called object of type kotlin.reflect.kclass. And Kotlin's k-class just has a property called .java. So that's how that works. If we look at k-class, it has all these different things that you can use to look at your class type. You can see if it's final, if it's open. These are actually all the same things that are in Java's regular capital C class, except it has a couple extra things that are Kotlin specific, like to find out if it's a data class, if it's a companion object, etc. You can also get its name, you can get its member variables, any annotations, its constructors, etc., etc. So you can reflectively look at the class that you're working on. You'll notice the Java thing isn't in here, though. It's actually defined as an extension function on the k-class type in the standard library. So that's how that works. So we saw k-class. That's one class type in Kotlin's reflection types of classes, and this is all of them. It looks a little daunting at first, but it really does make sense. So at the top, you have k annotated element. Below that are just all the things that you can annotate, that you're allowed to annotate. You can annotate classes, you can annotate callables, you can annotate parameters. A callable can either be a function or a property. A function can be a getter or setter. A property can also be a mutable property. So hopefully that's pretty clear. This was just another small example of using some reflection. So if I have a demo class with a method called callMe, I can use that same reference operator to get a reference to the method callMe. And then since that's a callable, I can call .call on it. So now I'm reflectively calling that method. Here's a much more advanced example of using some reflection. So that same demo class, you could, from its K class, you can get its primary constructor. You can get all of its properties and get the first one. From that first property, you can get the setter. That's the third line here. The fourth line is a little wordy, but if you look at it for a minute, it makes sense. You're getting the setter from that same property, and you have to do some casting on it. And then in code, you could call the constructor reflectively. You could call the getter reflectively. You could call the setter reflectively. And then if you were to print out this P1 value afterwards, it would be what you've changed it to. So it goes without saying, do not do that. You will see some reflection stuff actually in the standard library, though. So winding back to the very start of the talk, the observable delegate, we said the second parameter you pass to it is this lambda. We sort of glossed over the fact that the first thing in that lambda you get is a property, and then the next ones are the old value and the new value. So the property is actually of type K property, and that's what let us do things like print the property name within that lambda body. So you could also, on any of these classes, you could make your own extension functions that can be a little handy. So here's one on K property. You could do .log, just print out the name of this thing, and then get its getter and call that to print out what the value is. And then to use that log, you'd use the reference operator to that field and just call log on it. So you could do things like that in your code. I should say reflection is, you guys all know this, notoriously slow, especially on Android. So use it very sparingly, and if at all possible, don't use it in production. All right, the last section of this talk is on building DSLs. So there are really two big or main tenets in or features of Kotlin that let you make DSLs easily. And the second one we saw, infix functions. It's like that to operator where you don't need the brackets on things. The other one is something called lambdas with receivers. So just like infix functions, if you've never built a lambda with a receiver, you've definitely used them. So the with method in Kotlin uses a lambda with receiver. And this is the thing that lets you, within with, you pass in an object, and then within the lambda, you can act on that object without referencing it, right? So as opposed to something like .apply, where you have to add .it to reference the things. With a lambda with receiver, you don't have to do that. You can just call methods on the thing you're acting on. So this is two examples, one using a string builder, one using some class type that I would have created. And here's how you make lambdas with receivers. So it's pretty simple. So this is not a lambda with receiver. This is a regular method, a regular function that takes a regular lambda, that takes a string builder and returns nothing. And then in the method body, you would call it. So if you want to turn that into a lambda with receiver, all that you do is you take the type that the lambda is expecting, move it outside of the parentheses, put it before, and put a dot before it. So that's the syntax. You can call it the same way. So the difference between these two is the first one. When I call the first one, I'm getting that lambda is parameter that's getting passed to it is the string builder, right? So if I didn't put SB here, it would have to be it. Here I've just renamed it. But in the second one, because I've moved that string builder name outside of the parentheses with a dot, it's now a lambda with receiver, and I can act on it without referencing it, right? Right. If you have a lambda that takes multiple arguments, all you do is you take the first one out of the parentheses, again, put it at the start, and then it's the thing that's going to be the receiver type that you can call on without referencing it directly. So that's lambdas with receivers. Right, this is how you would use it. You can see in the second case, I'm not accepting a string builder, it's just accepting the last two arguments, and then I can call things on the string builder. Okay, so a lot of people have said they've had issues sort of processing DSL talks, and I think it's because people say, you know, we're going to build this thing, and you're sort of too worried about what you're trying to build versus the language features you're taking to build it. So again, I'm going to take a different approach to showing you how to build a DSL, and then we're going to make it something like a concrete example after the fact. Hopefully, if you've seen a DSL talk and it hasn't stuck, hopefully this will make it stick for you. Okay, so this uses lambda with receivers. So I have a thing, a class called thing, that is a function called t1, and that function takes a lambda with receiver on thing2, right? So now after I call thing1, now I can call things on thing2 without referencing it, right? Within thing2, I have a function called t2, which takes t3, which is the lambda with receiver on t3. So after I call t2, I can now call things on thing3 without referencing it. And then thing3, I just put done so that this wouldn't go on forever. And then I made a nice little top-level function that just makes a thing1 for me. So we've made a little DSL now where you can call that top-level function and call t1. Now I can call t2 on thing2 without knowing or referencing thing2 at all. And then within that block, I can call done on thing3 without knowing about it or referencing it at all. You can also just change the order of that code a little bit if you wanted to make it sort of more easy to parse so that it's not a bunch of classes that are nested with stuff in them. But, you know, functionally equivalent. So now, if I just rename some stuff, now we have built, the code's the same. This is actually a DSL for making some HTML. So hopefully that was a bit of a aha moment if, like I said, if other DSL talks have been a little too focused on what you're building, not how to build it. Yeah, and then we can continue to extend that if you want, you know, add more features to this thing. But that's how you use lambdas with receivers to build DSLs. That's all the content I have. Some further reading, I'd suggest this book, Kotlin in Action. It's very good if you haven't read it yet. There's a talk called 10 Kotlin Tricks in 10-ish Minutes by Jake. Hattie Harry from JetBrains did a talk called Kotlin 102. Christina Lee did another talk also called Advanced Kotlin, and her approach to it was different. It was a lot of live coding. And then probably my favorite talks of all time have been the 2 Java Puzzler talks by Anton Keks at Kotlin Conf, both this year and last year. So I recommend you go check those out. If you think you know anything about Kotlin, you go and listen to those talks and you realize you know nothing at all.